Good afternoon, students. So, yesterday we discussed the BCD adder, uh, and we have also tried to differentiate it with the simple binary adder. So, we see that there is a difference between BCD adder and binary adder. When we reach the values from 10 onwards, so up to 9, there is no difference between BCD and binary adders. So today's topic is this is the last topic of your first unit, barrel shifter. And one more thing that no one has submitted the assignment on the link I have shared with you on Monday. So tomorrow is the last day to submit the assignment. So just submit the assignment by tomorrow positively. So the barrel shifter is that it is a specialized digital electronic circuit with the purpose of shifting an entire data word by a specified number of bits by using the combination logic with no sequential logic used. Combination logic means no memory will be required. Now suppose barrel shifter is that the entire data word, the entire frame of the data should be transferred like this is a way, and we feel that this way word is wrongly placed, so we will shift it to this place. So this is the shifting, and the barrel shifting is that the whole word will be shifted either left or right by specified number of bits and by using the combinational logic, not the sequential logic. So the simplest way of achieving this by a series of multiplexers will be used where one output is connected to the input of next multiplexer. It is a serial multiplexers usage. So one output is connected to the input of next multiplexer in the specific chain, so that in that specific manner that depends upon the amount of shift specified. So how much amount of shifting is needed, that will be specified. Means number of multiplexers we are using will decide that how many bits will be shifted either left or either right. So they are specialized electronic circuits, and since the bits of binary data, only binary data will be used and often employed by embedded the digital signal processors DSPs and other processors to manipulate the data. It is then required for various low-level data applications such as floating point arithmetic operations. Floating point means decimal point arithmetic operations like 9.2, 10.23, 40.64 like this. So this barrel shifter is able to complete the shift in a single clock cycle. That will be a great advantage over a simple shifter where for n bits shifting we use the n clock cycle. So in barrel shifter, suppose this is the one cycle, and number of bits will be transferred either left or right in barrel shifter, whereas a simple shifter means n bits we want to transfer, and similarly n clock cycles will be used. Means in barrel shifter, if any number of word, if the clock cycle is 1 second, then any size of word can be transferred from one place to the other with a difference of some specified number of bits is 1 second, one clock cycle. Whereas in single or in simple shifter, n bits will use, n bits transfer will have n clock cycles. Clear? Okay. So this is the barrel shifter. So we will discuss it in the video I have found for you. So next is the arithmetic logic unit. It is the main component of central processing unit that stands for arithmetic logic unit and performs the arithmetic and logical operations. So arithmetic logical unit is also called as integer unit, that is the integrated circuit within a CPU or a GPU. That is the last component to perform calculations in the processor. Okay, what is this GPU? Can anyone tell me? And it has also the ability to perform all processes related to arithmetic and logical operations like addition, subtraction, shifting operations, Boolean comparisons, like this. So the binary operations can accomplish mathematical as well as bitwise operations, true or false. So arithmetic logical unit then be considered as it is separated or separated into two parts, AU, arithmetic unit, and logical unit. So combinedly it is called arithmetic logic unit. The operand and code used by the ALU tell it which operation have to perform according to the input data. So after getting the input, the output of the ALU will be sent to the computer's memory once the ALU completes the processing of input. So here the diagram of this arithmetic logical unit, fetching instructions memory from the memory. So here the main memory to control unit and decoded the instructions into commands. So then the instruction is you press the save button. So that means the instruction of save command will save will convert it into commands. Here the commands will be executed and then the results are being stored in the memory. So this is a very simple process. Main memory, from main memory it will shift to control unit. Control at the control unit, the instructions of saving or copying or moving the data will be converted to commands, and then after converting the commands will be executed at the ALU, and then after processing of the ALU the results are stored in the memory. So some operations performed by ALU are, as we discussed, that it is logical operations. So as in the name, that logical operations could be performed like NOR, NOT, NAND, or XOR, XNOR, and more. So bit shifting operations are there. Some barrel shifters will use ALU to shift the number of bits from one point to another, or to shift the bits to a specific number of bits, either left or right. So that is also known as the multiplication operation. And then arithmetic operations, it performs the addition and subtraction, and it also performs the multiplication and division, but that will refers to the bit addition and subtraction, because in the language of computers or digital circuits, the multiplication and division operations are costly to make. So in place of multiplication, addition can be used as substitute and subtraction for division. Okay, so these are the web references. So you can refer from it. Let me just show you a video.
Today's topic is about barrel shifter. So before going to barrel shifter, make sure you hit that subscribe button and turn your notifications on so that we can get connected and
Yes, students' voice is audible. Yes. Is anyone there? Okay.
And if you have any doubts, comment down below. I will respond within 24 hours. So now let's go with the barrel shifter. What's a barrel shifter? So barrel shifter is a digital circuit that can shift or rotate a data word by a specific number of bits without use of a sequential logic gates. That means a barrel shifter is a combinational circuit. Okay, so barrel shifter is used to shift or rotate a specific number of bits in the modern microprocessors. So why are we using it in a modern microprocessor? Because it takes a single cycle, understand this, it takes a single cycle to shift or rotate n bits. That means that is pretty fast, okay? So I can give you an example where it is used. It is used in the ARM processor along with ALU, okay? Now let us see an example of a 4-bit barrel shifter which can perform the operation rotate right. So I'm going to discuss how to rotate right using a barrel shifter using a design with 2:1 multiplexer, a design with a 4:1 multiplexer, and a design with a transistor. So we are gonna see the 3 of them. So now let us go with a 4-bit barrel shifter which is gonna rotate right using 2:1 multiplexers. So this is a barrel shifter which can perform the operation rotate right. So this is a 4-bit barrel shifter. So now let us look at it, how it works. So as you can see, we have a 4 multiplexers over here and a 4 multiplexers over here. So this multiplexers will perform a certain operations and this multiplexers will perform a certain operations. So K1 is a select line for this all multiplexers, K0 is select line for all these multiplexers. So now first let us look at this multiplexers and go for this multiplexers. So what is the operation performed by this multiplexers? So let us see it. So when K1 is 0, that means the select line is 0 for this multiplexers. So every multiplexer has a select line K1. So what happens is that when K1 is 0, P0 is A0, P1 is A1, P2 is A2, and P3 is A3. So that's what's happened when K1 is 0. What happens when K1 is 1? So P0 is getting A2 and P1 is getting A3, P2 is getting A0 and P3 is getting A1. So that's the basic operation of multiplexer. So but as you can see, one important note is that A0 position has been taken by A2 and A1 position has been taken by A3. This happens when we shift.
My job is to make college easier because students have a lot on them.
Shift the data. Okay, when we shift the data by 2, if it's a 4-bit, if we shift the data by 2, then A2 will come at A0 and A3 will come at A1. So the remaining 2 bits are being occupied by A0 and A1. So this 4 multiplexers will perform an operation of a rotate right. Okay, rotate right by 2. When K1 is 0, what's the output? P0 is A0, P1 is A1, P2 is A2, and P3 is A3. So there is no shift in the operation, just a normal no operation. So when K1 is 1, so what is the operation we are going to perform? We are going to perform rotate right by 2. That means A2 has been shifted by 2. So A2 is first one, and then A3, and then A0, and then A1. I hope you get it. And I'm taking the combinations of K1 and K2, K0, okay, 0, 0, 0, 1, and 1, 0, and 1, 1. So now let us go what happens with the K0 multiplexers. So as you can see, this is used to perform rotate right by 2 and this will perform rotate right by 1 because when K0 is 0, P0, P1, P2 and P3 will be transferred to Y0, Y1 and Y2 and Y2 respectively. Now when K0 is 1, we are getting Y0 as P1, Y1 as P2, Y2 as P3 and Y3 as P0. Okay, so this is used to perform rotate right by 1. So now let us see the truth table, what's happening when K0 is 0 and K0 is 1. So K0 is 0, that means it will transfer P0 first, that is A0, and next Y1 equals to P1 and Y2 equals to P2 and Y3 equals to P3. So when K0 is 1, then Y0 is equals to P1, so Y0 equals to P1, Y1 equal to P2 and Y2 equal to P3 and Y3 is equals to P0. So it is P1, P2, P3 and Y3 will be equals to A0. So now let us see with this one. since it's k equals to 0, it will pass on directly, that is A2, A3, A0 and A1. Okay, now it's 1, so first we will get P1 data, then after P2 data, then after P3 data, and then at last we will get P0 data. So I hope that's clear for you based on the truth table. So now let us look at the operations performed when K1 and K0 are 0. That is, no operation is performed, no shift are performed. Whatever the input is, A0, A1, A2 and A3 are perfectly aligned. Now if we say that K1 is 0 and K0 is 0, as you can see, A1 is shifted right and A0 is rotated. So this operation is rotate right by 1. So again, A2 is being shifted over here by 2 bits and A0 and A1 are rotated. So this is rotate right by 2. So this is A3 is being shifted by 3 bits and A0, A1 and A2 are rotated. So it is rotate right by 3. So by this you might understand that this multiplexers is performing operations of rotate right by 1, 2 and 3. Okay, this is a logarithmic barrel shifter. Okay, as you can see, now let us consider how many multiplexers do we need to perform this 4-bit. So let's say we have an n-bit data and we want to design using 2:1 multiplexers. How many multiplexers? We require n log 2n multiplexers. Let's say if we have 4 as n, that is 4-bit data, that is 4 into log 2 of n, that is 4 equals to 8. So we require 8 2:1 multiplexers for a 4-bit. Okay, that's what we got. As you can see, that's what we got, 8 multiplexers. Now let's say we want 8-bit data. So for 8-bit data, we require 24 2:1 multiplexers. Okay, 24, that's too much. So we require 24 2:1 multiplexers. So one more important thing to note about this is that, see, as you have seen that 4 is 2 power 2. In terms of power of 2, 4 is 2 power 2. So we are using 2 power 0 and 2 power 1. Now if we want to build an 8-bit barrel shifter, we are going to use 2 power 2, 2 power 1 and 2 power 0. Okay, so this is to build an 8-bit barrel shifter. I'm going to give an example using 2:1 multiplexer. So we will be having connections like that. This is not the exact connections, but this 2:1 multiplexers, there will be 8 over here, 8 over here, 8 over here. So but this multiplexers will perform an operation of rotate right by 4, and this one will perform rotate right of 2, and this one will perform rotate right by 1. If it is an rotate right operation, rotate left, this will be 4, this will be 4, this will be 2 and 1. Okay, in that fashion. It is in logarithmic fashion. As you can see, if we want to go for 16, then we will have a number of multiplexers will increase, but the logic remains the same. You know, we will use lesser bits, that is 2 power 8, 2 power 3. So it is 2 power 3, 2 power 2, 2 power 1 and 2 power 0 if we were going for 16. If we are going for 32, we are not going to use 2 power 5, we are going to use from 2 power 4 to 2 power 0. That's how we are going to use. So this is going to perform shift by 8 or rotate by 8, rotate or shift by 4, rotate or shift by 2, and rotate or shift by 1. I hope this might be a confusing one for you, but if you design it, that will be an easy task for you to do it. So now let us look how a 4-bit barrel shifter is performed using a 4:1 multiplexer. So this is a 4-bit barrel shifter, the same rotate right operation. So as you can see, Y0, Y1, Y2 and Y3 are there with the select lines K1 and K0 for each multiplexers. So what's the change in here? There is nothing changed. We have used the outputs which we got from our multiplexers and given as the inputs for each multiplexers. As you can see, A0, A0, like this you can see, A3, A0 and A1 has been given to Y3. So A3, A0 and A1, A3, A0, A1 and A2 has been given to the inputs for Y3. So now for Y2, this is the Y2 column, A2, A3, A0 and A1. A2, A3, A0 and A1, and so on. For Y0, let's consider A0, A1 and A2 and A3. So A0, A1, A2 and A3. So these are being given as the inputs. So this is a clear diagram. As you can see, it looks better than 2:1 multiplexers, but you know that as we go on, if we keep on increasing the multiplexers size, it will be a problem. So mostly you must use 4:1 or 8:1. That's it, not more than that. Then that it will be a problem. So you must learn how to design using 2:1 multiplexers for sure. So this is how it is done. Now let's go for a shift right arithmetic barrel shifter. example of a barrel shifter which is shifting arithmetic right. Okay, don't be confused by the big diagram. It is nothing big. It's a simple small circuit which is using a pass gate logic. So as you can see, we have inputs sh0, sh1 and sh2 and sh3 to decide the arithmetic shift, and the inputs
Make your mark in the most emerging industry of 2021. Postgraduate program in AI and
inputs are A0, A1 and A2 and A3. These select lines are mutually exclusive. That means if SH0 is turned on, other three will be turned off. SH1 is turned on, SH0, SH2 and SH3 will be off. So this happens. So now this is shift right arithmetic. It's not shift rotate right, okay? This is shift right arithmetic. So what are the operations will be performed when shift right arithmetic is performed? So let's say when SH1 is selected. So SH1 is selected. As you can see, the path is like this. Okay, this path. There you go, there you go. And SH0 path is like this. So now let us go with SH0. So when SH0 is selected, as you can see, it is connected to A0. So we'll get B0 as A0. So these are buffers which we'll use to store the data, that's it. So B0 is A0, and when SH0 is high, so B1 will be A1. So as you can see, A1 is selected, and B2 will be A2, and B3 will be A3, and so on. Okay, if you get more, if the number of bits increase. So now let us go with SH1. When SH1 is selected, there is an important thing is that we are sending B0 as A1, okay, and B1 as A2, and B2 as A3, and B3 as A3. Here, as you can see over here, it should be A0 if it would rotate, but it is not rotating, it is shifting right by arithmetic. So we need to extend the sign. So the sign is extended over here, A3. Now let's go for SH2. SH2 is here, so it is B0 as A2 and B1 as A3. So B1 as A3. So now what will be B2 and B3? It will be A3 and A3 because we are shifting right arithmetically. Okay, arithmetic means we need to take care of the sign, so A3 is there, and SH3 it will be all A3 because we have decided it like that. So that's what happening. Okay, I hope you guessed. This was a very fast one, shifting right arithmetic. So I'm concluding it right here. So this is how you can design using a 2:1 multiplexer, 4:1 multiplexers, a barrel shifter. I hope you got a brief idea about the barrel shifters. And if you want more brief idea on rotating left and shift and rotate at the same time, so I'm gonna make a series of videos for you. And please make sure you subscribe and hit that notification bell. And one more thing, like this.